Now children, in this video we will study the next property, electronegativity. You have fair idea about it from class 9th and 10th. It is the tendency of an atom to attract the shared pair of electrons towards itself in a covalent bond. Simply tendency to attract the shared pair of electrons towards itself in a covalent bond. It is the property of a bonded atom, not an isolated atom as you had seen other properties. Second thing, since it is only a tendency, so no unit, nothing to do with energy or something here, no. Now children, what all factors govern the property of electronegativity? Effective nuclear charge, but obvious, greater the nuclear charge, effective nuclear charge, more will be tendency to attract electrons towards itself. Hence, higher will be the value of electronegativity, in short En. Size of atom. I tell you same thing being said in a bit different manner. So if size decreases, force of attraction increases, En increases. So if size decreases, En will increase. So it is inversely proportional. If size increases, En will decrease. If size decreases, En will increase, because it goes according to, again, your effective force of attraction. Size decreases, force of attraction increases, En will increase. So these, in a way, these are more or less similar points conveying the same thing but in two different ways. Third is oxidation state. Children, yes, I know you have not been taught the chapter oxidation reduction in detail, but I just tell you in short. Don't worry, this point will be more clear to you when we will be taught the chapter redox. Right now, suppose we have monoatomic ions like ferrous, ferric, cuprous, cupric. So they have charges. Those charges are actually their oxidation states. Those charges which are there on the monoatomic ions like ferrous, ferric, cuprous, cupric, plumbous, plumbic, those kind, that reflects their oxidation state. So point says higher the oxidation state in positive, greater will be the En, electronegativity. Like ferrous and ferric. Naturally, ferric will have the higher value of electronegativity, will have more tendency to attract electrons towards itself. I hope you're getting some idea, and it is reflecting also. Clear also, more positive means more need of electrons will be there. So easy attraction will be there. So more tendency will be there and greater will be the En. Similarly, cuprous, cupric. Say cupric is what? Cu2 plus, and cuprous is Cu plus. So definitely cupric will have more tendency to attract electrons, or say it will show greater En. Then children, hybridization. Yes, it's a new term for you. I know you don't know. This will be taken up in the chapter chemical bonding, but just want to tell you in short. For this hybridization, we'll be mainly taking it for carbon, I tell you. Carbon shows three hybridizations, sp, sp2, sp3. Yes, I know right now you don't know. Don't worry, we'll see in chapter chemical bonding how to find out. Now suppose we have been able to find out the hybridizations of carbon as sp, sp2 and sp3, whatever is there. So point says, logic says, wherever we have the higher value of S factor, S character, greater will be its electronegativity. So where do we have greater S character? Sp, one part S, one part P. So 50% S, 50% P. In sp2, one part is S, two part is P. So total overall S is 1 by 3, right? So 33.3% or say 33.33%. In sp3, one part is S, three parts is P. So S is 1/4 means 25%. And the logic says greater the S character, greater will be the electronegativity. So children, wherever we have carbon in sp state, it will show the highest electronegativity, and wherever it will be in sp3 state, it will show the lowest electronegativity. This much is enough to understand at this point. Rest will be more clear when we do chemical bonding. Then children, the trends. In a period, left to right because the size decreases, En increases. In a group, top to bottom because size increases, En decreases. Let us summarize. In a period left to right, children, your halogens have the highest value of electronegativity. Or let me say, halogens are the most electronegative elements. For inerts, this point does not arise because inerts do not have tendency to attract electrons. Hence, this point has no sense if we talk of inert gases. It makes no sense there. Simply, in a period, inerts have the highest value. Okay, sorry, my mistake, slip of tongue. Your halogens have the highest value of electronegativity. They are the most electronegative elements. Fine. And in a table also, as you move from left to right, electronegativity decreases. This idea you have from class 9th and 10th. Now children, out of all the elements known so far, we know halogens are the most electronegative. Correct. Out of those also, F comes on top. Correct. So F is the most electronegative element. Number one. Number two, we thought should be chlorine. No. It was found to be O. O is oxygen is the number two most electronegative element. These are the relative values. F was found to be given value 4. So, with respect to that, O was found to have the value 3.5. Then was N and chlorine. Nitrogen and chlorine, they had almost the same values, 3.0. And then it was carbon having value 2.5. So, in a way, these are the elements which are the most electronegative elements known so far present in your periodic table. F is the most electronegative element. Number 2 is O. N and Cl have almost same, and C is number 4th here. Or you can say it comes as after these F, O, N, Cl and then C. So these two have same. You can call it at number 5 also, because these two are same, or say value wise it is 4, 3.53 and 2.5. N and Cl both have nearly the same values. So first off F, then oxygen, then Cl and N both nearly same, and then C. So this is what we have seen. Inert gases have no tendency to attract electrons. So this is all for children, your electronegativities. And this very high value of electronegativity and the small size of F makes the F element most reactive element known so far, all by chance. So this is all because of very high electronegativity of F, right? So F is the most electronegative element known so far. So these points you had to know in short for electronegativity. I know this will be and slightly may not be that clear to you right now, but don't worry, I just gave you the required thing here at this point of time. Rest we will do when we take up chemical bonding. So I stop here for this electronegativity and for this video. Hope things are clear to you. We stop here. Okay? Thank you, children.